All right, hello, welcome to Wellrailed. Few new faces, that's pretty cool. Yeah, we have a couple of speakers. One couldn't make it last minute, so we had a recording of that, but there'll be time for questions. We have Paloma people, Nick and Michael. Maybe some others hiding. That's all. Okay, only a couple of minutes late. This is good. Right, yeah, thanks very much to Paloma from the Meetup Table for hosting and sponsoring this meetup. And Jordan and Nick and Michael couldn't make it for doing all the organising. First speaker is going to be Tom, telling us about bundling. Yeah, representing GitLab.
Hello everyone, how are you all today? Let me share my screen, not Zoom, not this, slides. Can you hear me? Yeah, cool. So today I'm going to talk about bundler. A little bit about myself. My name is Thong Kuah. My claim to fame is that I have a grand total of 3 commits in Rails core. I think that was to do with the fix of about 10 years ago. Counts. And I was also the first GitLab team member in New Zealand. Yeah, I think they now have 30 over. So that's cool. So we're going to talk about bundler today. It's like hands on who likes bundler. Oh, not everyone. Okay. Does anyone want to shout out their favorite package manager, like PyPy or other things? Yarn, anyone? Yarn's better than NPM. Yeah, they're all good. Cool. So today's talk is going to be about hacking bundler, basically, as in the nice hacking, contributing source code. And we're going to talk a bit about how to monkey patch bundler. Hopefully, learn a bit about how bundler works and how bundler is implemented. And yeah, profit. Whatever currency or knowledge. So just a little bit. Hopefully, you all know what bundler is. Just recap a little bit. So bundler is basically the de facto package manager for Ruby. It's basically a package manager that installs Ruby gems. And here's an example gem file. And you basically specify the gem that you want, say Rails, and then you can specify a version restriction or specification. So here we say, please install Rails 7.1x. It's to be more than that version. So you can do a lot of restrictions as well. And you can also have platforms as well. So basically, besides versions, there's also these things called platforms. Now, 99% of gems is basically the Ruby platform. So it's basically platformless. So if you install it, it's the same Ruby code everywhere. But for some gems, because there's C extensions, I think that's the only reason, they need platform-specific code. So for example, Nakagiri, they have C extensions that will compile, that needs to be compiled differently on a Mac. So on a Mac, you probably use Clang. On Windows, I don't know, you're probably using the Windows core code to compile it. So the way that bundler or Ruby specifies the gem is that you have that version number. Actually, it's not really a number, it's a string, and then dash and then platform. So for example, ARM64 Darwin, which represents the M1 version of macOS. So other types of examples of platforms could be like Java, x86, Min, W32. I think that's Windows, but they're always incomprehensible in time. So you have to look it up. Basically, our bundler will help you. So what is the problem that I encountered? So basically, there was this vulnerability that appeared in bundler a while ago, and that was fixed and everything. But we wanted to kind of additionally harden things a little bit. So the problem is that given Ruby gem version in a platform, we need to ensure that bundler is installing that thing and not some kind of like hack version that someone has poisoned the AWS cache with. So to kind of solve that, the answer is basically checksums. So every Ruby gem has a SHA-256 checksum. So if you visit the Ruby gem page for a gem, you can see at the bottom of the page there is SHA-256 checksum. There's also SHA-512 checksum as well. Look into it, but the most common one is 256. And the gem, the checksum is actually for each platform and each version. So how the checksum is generated is that it's basically checksum of that file. So every gem that you install actually downloads a gem file. It ends with a .gem, but it's actually a tar with it. And because it's one file, then it's really easy to checksum that file, and that checksum should work, right? And if you look at Rails, hopefully that's the correct checksum. So how can we make use of that checksum? So the first and most obvious way, if you follow that security vulnerability advisory, is to use this new gem that's called bundle integrity. And what bundle integrity does is that it checks all gems that you have installed in your bundle versus the checksum that's stored on rubygems.org. So it basically just checks through all the gems in those directories, does checksum, and queries up to rubygems.org. So this is great. This is good, but unfortunately, it's post-install, so it doesn't exactly stop a bad gem from being installed. So it's kind of post-effect. Now, ideally, we want to kind of stop like the gem being actually installed and start running code and say post-install code if the checksums don't match. So I looked around and eventually created a bundler plugin to do this. Actually, it started out live as a bundler plugin, but it's now the gem one. So actually, bundler does check checksums for you when it installs, but because of backwards compatibility reasons, sometimes it skips it. So like there are like some older gems, for example, where the checksums were generated by company. So there's a lot of like edge cases where it just skips it. But you can rely on that. But we want extra protection. This is what I did. And you can check it out in that link there. Unfortunately, kind of it's pretty experimental. So it's a vendor gem within GitLab, but it's under MIT and it's going to extract it up. It's really cool. What it does is basically it extracts out those checksums that I was talking about and prints it out into a separate file, a gem file.checksum file, so that the idea is that you commit that file. So once you committed that file, and then anyone that checks out your Rails application, for example, can now use that checksum file to compare this when installing gems for their laptop or for CI. And if the checksums don't match, then it just stops it. And the way that I made it stop is by monkey patching bundler. And here's how we monkey patch. You basically put Ruby code into the gem file. This is something that Stack Overflow and Google didn't know about, or at least my Google search skills were bad. But eventually, I found this out by looking at one other bundle plugin. They basically just put Ruby code. So you can execute Ruby code in the gem file, which is not that nice, but it works. So this works. This works so hard in things. Unfortunately, still pretty experimental, and also it requires you to install additional gem after bundler. So the ideal solution would be to kind of move this code into bundler itself. And this is an example of the checksum file. You can see it's basically just a JSON of the gem name, the platform, and the checksum. And you can see also all the different platforms that MicroGA publishes. It's a lot, but that's dedication right there. Okay, so bit. So as I mentioned, I wanted to push the code that I have into Bundler itself so that I don't have to install separate gem. And that's what I did. Here's the draft pull request that I did. Unfortunately, it's not finished yet. So what I want to talk about is all the things that I've learned and all the things that I've fixed through it. And also, yeah, it should be quite cool because the bundle is really cool. So that pull request, what it did is that instead of introducing a new file, we introduced a new checksum section within the gemfile.log section. Is everyone familiar with gemfile.log? Yeah, okay, cool. Gemfile.log is a mouthful, so I'm going to refer to it as a log file from now on. Not easy to say. And in the log file, you have the gems that you're installing, the platforms that you're installing for, the dependencies, and what bundle version you're used for. So my pull request introduced this new section called checksums, because it is checksums. And you basically have the gem name, the version. Well, this is how bundle refers to. It's actually a version plus platform together in that brackets, and then the SHA-256 checksum. So there were a few interesting things while trying to come up with that pull request. So the first one is, how do I even get that checksum? And I'll show you how. And the second thing is, when do I use the checksum? And the third thing is this platform, which I'll talk more later. So to extract the checksum and to commit it into the log file, it's quite easy actually. You can basically, Bundler has access to the gem. So so you got a gem class that represents a gem that's going to be installed. And the gem knows what cache file it's using to install it. So you can pretty much just have access to the cache file method and just generate the SHA-256 sum from that. So this is how you do it. And bundler, you're going to have to help with SHA-256 digest. And then once you have that, I just created a new checksum object. I passed the checksum object to the class that generates the log file. So that's pretty easy. So this part of the code here, unfortunately, exists after you install. So it's run after you install. So it's still too late to use that information. So I needed to kind of get the checksum a bit earlier in the process before it created a cache file. Actually, no. After it's done with the cache file, but before it installed the cache file. So yeah. So to do that, I needed to understand a little bit more how bundler works. So this is how bundler works. In that we have this bundler first parses the your gem file.log, all the different gems that it does, into what it calls a definition class. So there is a definition class inside bundler, and in that definition class, it then creates a collection of lazy specification class. This lazy specification class, it represents each gem that bundler needs to install. And it has the gem name, the version, and the platform. And it's lazy because it's not doing anything. It's not installing. It doesn't know whether it needs to be installed or not, and so it doesn't run network operations. And then because like bundler has few subcommands, right? So for example, if you run bundler check, you're telling bundler not to do anything really, just kind of check stuff, right? So it's going to remain lazy. But if you run the bundler install platform, that means you're telling bundler to do work, and it stops being lazy now. It's going to call the materialize operation. And when it calls the materialize method, it converts itself into either start specification. I don't know why they call it start specification. It's basically I'm already installed specification because that gem's already installed, so I don't need to do anything else. Or it converts it into endpoint specification. Basically what it means is that fetch this gem from some endpoint. such as rubygems.org. Now that you've got to have the endpoint specification, then Bundler does extra work to fetch the necessary JSON files to say, here's the gem information, here's where you can fetch files. And conveniently, it also has checksum as well, return from the JSON. So yeah, so you can quite easily just use that checksum method from the endpoint specification. And here's how it looks like. So because the checksum is basically just an attribute on the endpoint specification class, I just use that and then create my bundle checksum object. You can see this code in context if you follow this link at the bottom. That's right. Cool. So that all works nice and good until I realized something that so if you notice the endpoint specification, it represents the fetch version of that gem, and that fetch version of gem is specific to the gem, the version, and the platform. So if you're installing Nokogiri, it will only fetch Nokogiri for your laptop, which is the Mac OS. It won't fetch any information about the Nokogiri gem for Linux. So it's going to be really hard to commit the checksum, because what will happen is that I, working on the Mac OS, will install, say, the gRPC gem, it fetches the Darwin version of it, and gets a checksum. I create it in block and then commit it into the log file, which is great. But then I'm missing the Linux version of it. So if my code it goes and gets my branch and bundles installed, they'll be missing the checksum, and then they have to make another, which is just a bad story. It's a very bad experience. And even worse, on CI, for example, we usually run bundler install --frozen. If you don't know, I advise you to, because it really warns you against accidental things. So what basically frozen does is that if bundle detects that the log file has changed as a result of that bundle install, it will error out. So that's especially useful on CI, where you really don't want the log file to change, right? And here, you will encounter that situation where you commit the Darwin stuff, and then CI runs bundle install frozen. It now detects that the checksum has the Linux and the Darwin one, because I didn't commit the Linux one. So it just errors out. So that's basically where I got stuck last Christmas. I was working on this problem. So yeah, do you have any bright ideas on how to resolve it? Feel free to go to that link and give me a hand. You notice also that link is not my PR. The one that's open source, someone else actually copied my PR and continue it. So yeah, that's awesome. If you want to help them out, awesome. Yeah, so that's basically my journey in Bundler for the last few months. What I didn't talk about was that the Bundler repository is really quite well organized, that I can self-discover all the things, which is nice. It's also really nice in that they have a lot of integration tests as well. So they really don't have much unit tests. So they have integration tests in that test that for this given gem file, for this given log file, I run this command, does it make sense? Does it make sense? But because I had a whole new section, I had to update like 70 tests, or no, hundreds of tests, which is not fun. Anyway, just to recap, here's a few key classes that I've discovered in Bundler related to this thing. I'm not going to talk about how Bundler resolves dependencies and things, that's a whole separate section. So we talk about definition, and basically we use the definition plus the log file parser to pass the log file, and it passes the log file into gems. And if you decide to install, you either say, okay, I've installed it, so create materialize into stub, or materialize into endpoint specification, because I am going to install it. And for Ruby gems, for gems that come from Ruby gems, if you look at that class, the bundler source Ruby gems, that's where the methods that contain all the information on how to fetch the checksums and all the different JSON things. And then once you've done that, you come back to the definition thing, run the log file generator to write out. So that's kind of how everything hangs together. There's no documentation. This is what I worked out. So all mistakes on there. Yeah. So that's basically it. Thank you very much. Oh, you can find me at this address. That's all my contact details. If you have any questions, yeah, and the slides, so I'll post it from Jordan. Yeah. Cool. Thank you. Yes.
Go on. Is there anything that means that wouldn't your extension would non-reviewed source?
Is there anything
that artifact preserver or something? Could you just drop it? Do you rely on that review?
Yes. I don't think there's anything that's specific to RubyGem. As long as your endpoint provides the checksum, then it should work. But I'm not sure whether the format is universal. Like, I think if you run a private RubyGem server, it's the same as the normal RubyGem server. Yeah, but I don't know if I can. Yeah, I don't know. So I don't know. So there's a few bundler source things, right? So the bundler source RubyGem as well. There's bundler source path, bundler source Git. I don't know where artifact is set. So yeah, it might be. Yeah. So it wouldn't have that special checksum. Yeah.
Were you working on this as part of your work at GitLab, or was this like a personal interest project?
This is kind of from a GitLab. It's a GitLab problem. To say that the hardening is in GitLab, but it's also a personal interest. So, when I was fixing the tests, it was just fun with it and something better to do. Yeah. Oh.
Have you seen any bad actors pushing things, taking them through this method yet?
Good question. So we had this one. So this is live. It's been running on CI for the last 4 months now. So far, no. Yeah. But I think probably because the RubyGems of people are really onto this. Kudos to them.
Existing code that check the JSON cache files. It's not extra the cache every time you support the cache. And if you reinstall from the cache.
You mean which cache? This cache file?
Yeah.
Yeah, that's why this is not that great. So in subsequent revisions on IPR, I'm actually looking to check some form and install them. Yeah. Oh, awesome. Come talk to me afterwards. I'll be hanging around, and feel free to send me an email or join the bundle Slack as well. Cool, thank you.
Hello, everyone. My name is Saurabh, and I'm an engineering manager at Paloma. My talk today is about going from zero to marketplace in the space of 2 months. Yeah, we really did that. First, a brief introduction about Paloma. Paloma is part digital studio, part venture studio, and part venture capital fund. In the digital studio side of things, we actually partnered with a lot of clients of ours to build their products from zero to, like at scale. Paloma Ventures, we partnered with day zero founders, worked with them on building their ventures and products from scratch. And venture capital fund, well, it's a venture capital fund. About ChemCloud, the product that we are talking about today, ChemCloud is a digital platform that makes it really easy to discover, buy, and sell chemicals. So you can focus on innovation that truly matters. Some of our clients are actually really innovative. For example, we work with Great Wrap, a cling wrap company that makes biocompostable cling wraps. For great rap, all they have to focus is on creating a great product that's very environmentally friendly. Their focus today should not be how to source their ingredients, which was the case before ChemCloud came along. So now they put up their requests. They even because a lot of the requests are repetitive, they put the request in the system and they keep sourcing the chemicals with a lot of ease, without a lot of friction from the process, without getting back and forth, going back and forth with different vendors, getting quotes and stuff like that. So they create a they create a sourcing request on the platform. Um, we get them quotes from different vendors. They decide which quote they want to go from. They can compare them side by side. And then once they decide which vendor they want to go with, they just place an order. They can also see what's the status of the order and also communicate with them through the platform if they wanted to. So yeah, ChemCloud gives them this whole full life cycle of procurement for the ingredients for the products, which makes it really easy for them to just takes a lot of hassle out of like just going back and forth and haggling with a lot of different vendors. Now, the problem statement we had in October 2021 when we were commissioned to build our first version of the platform was we wanted to build a fully functional platform that's rock solid, but also allowed for future expansion of features because they already had a very rich roadmap based on what they have been validating and testing with the customers already. Speed was of essence because we had promised our customers certain things that we needed to deliver in the first version of the platform. We had only two engineers to build the platform, and we had both for full stack, and we wanted to build front end, back end, everything, and we wanted to launch a platform around Christmas. Now, I know Rails, and I've worked on Rails for several years before, almost like 16 or 17 years now, and uh, so I was a little biased towards Rails as a choice of framework. However, around December 2021, Rails 7 was supposed to be released, and it was still in beta in October. So we thought, why not just start with Rails 7 now and just adopt the final version when it comes along? There was also this promise of Rails as one person framework since after Rails 7, which was very enticing because we were pretty short on the number of people that were required for the build. And finally, we had an option of building the UI with Tailwind UI to go with the maximum speed. Because Tailwind UI provided us with a lot of like components that were pre-built, and it was pretty easy for us to build things like design system and shareable components across the system. Now, tech stack, well, obviously Rails 7 and Ruby were the choices that were thrown in by default. PostgreSQL was a primary source of truth database. We use Redis as a cache store, and Redis also for Sidekick. We had for production we had two different configurations of Redis as suggested by the Sidekick wiki, where one of the Redis is actually configured as a persistence database for persisting the jobs in Sidekick, whereas the other one is the caching database. We use TypeScript and ESBuild. ESBuild comes in with with inbuilt support for TypeScript, so we thought, yeah, why not? Why not just use TypeScript with Stimulus.js as a JavaScript framework? We also used Hotwired and Turbo, which were really new at that time, and which was really under heavy development when we actually started it. Um, and it looked very enticing because some of the features that we wanted to build were building things like real-time chat, and like sending out notifications, creating an activity feed, and those kind of things. Hotwired Turbo really fit the bill really well in that regard, and because we wanted to go at a super speed, I thought sticking as close as possible to this stack was a great idea. And Hotwire Turbo definitely helped because it gave you all those features that you would look at in building like a single page app, or give that really rich feel to the application, deliver data in real time, things like that. Our gem stack actually looked pretty standard as well. Some of our gems actually helped us go really fast in terms of some features, like, for example, device, pretty standard, get our authentication and authorization very fast. We also had our device configured slightly differently. We had two different installations of device within the same, not really installations, but we had two different user models. One that managed the admin user space, and the other one that managed the main user space. We also have uh, device ZCXVPN, which is an entropy calculator, and was there for like password security, just to measure the password strength and things like that. We had device passwordless added more recently, just to ensure we have like magic links and provide people with passwordless logins. We had Rollify to add roles like buyer and seller and things like that. We had Pundit to do the authorization and set some rules around who can access what and what kind of dashboards can be accessed by whom, things like that. We used View components, pretty popular gem these days, because obviously a lot of us come from this thinking model of building components and component hierarchy. View components gives us that nice line of like um, building components just like React, and then rendering them anywhere. These components are shareable. You could build a design system with them, and there's a lot of good advantages to it. Apart from the speed, which obviously is much faster than just rendering partials across the system. We also used Notice Gem, which is a gem for delivering notifications, and ChartCake for building the charts. I think some of these things definitely helped in the speed side of things, because the community is really good around some of these gems. These gems are pretty standard across the board as well. We also got like they are very feature rich as well. So like if you wanted to if you wanted, say, for example, a full blown authentication and authorization, you can actually build, just have device and Pundit and then just configure it. Same goes for things like Notice and ChartCake, and you had charts running in no time. I might have missed a couple of them, maybe like I think pagination and stuff like that, but you get the point. The point is the whole community around these gems is really strong. The amount of features they provide, they're so feature rich that you can pretty much build anything that you want that's related to that particular feature. Um, there's also, for example, with Hotwired and Turbo, we wanted to build things like models and the chat and activity feed. It helped us things like, for example, with turbo streams, you could actually stream the data between different types of entities, and that helped us a lot in building the real-time chat between an admin user and an actual user. We even had like it was pretty easy to even connect two different user models with each other and then pass messages between them. And we went from that like from zero to chat in like a week's time. So we actually built production grade chat in less than a week, which is a big deal. And it all happened because Rails came with this feature where you can actually stream an HTML over WebSocket and deliver a fully feature-rich HTML with all the data decorated in it to the other side of a WebSocket. So all you had to do is render it and pass it through a controller. And we had all sorts of other things, like you could hook it up with a view component. So you're actually passing a Ruby class to it and just rendering a component rather than sending like a partial or a big chunk of HTML. We also had models, really interactive models, like ones with workflows like, okay, let's generate an order. People can see terms and conditions, go through the whole process of like, if I click on this, it goes to this. If and it has some decision making parts as well. So uh, if you say, if you have a purchase requisition number, you can enter that. If you don't have a purchase requisition number, you can say generate it for me, and things like that. So this whole workflow based on models was actually built with Hotwire Turbo as well, and there were pros and cons to it as well. For example, with Hotwire Turbo, we had this issue of documentation was being very sparse. A lot of time we had to actually wrangle through the GitHub issues, look at them, and uh, see what people have suggested or what worked. Involved a lot of trial and error and stuff. However, with Rails community being so awesome, I think a lot of people had already started writing blogs and things like, oh yeah, maybe this is a workaround that you can do. This is like a nice tip on on say Hotwire Turbo. Oh, if you want to have a delete, oh this is how the new syntax looks like. You have to add data turbo for the delete link to work now, and things like that. So these like a lot of things that were still not documented properly in the Rails core documentation, but were actually just floating around in the community. So you had to look for it, but it was always there. Uh, and for hosting, we started with Heroku initially. It was easy as just to start with Heroku. I know most of the people know what are the benefits of Heroku. We were obviously very strapped with the number of people we had. So choosing a pass was a no-brainer because we didn't have time to sit and configure an AWS configuration or something like that. Going for Heroku helped us go to the speed. We also had go to market at a good speed. We also had this thing called review apps that we were using. So for every pull request, we would spin up a new environment, and we would use that for testing. So we had only one long running branch called main, and we would do all the QA on the review apps. Somewhere around March or April last year, we had this issue with Heroku that with the whole logs being leaked, and then they disabled their integration with GitHub for a long time. So we were in this place where we were trying to figure out how do we keep going within this review apps process because there was no GitHub integration available anymore. That's where Railway stepped in. It was a good replacement for Heroku because you could have staged based deployments there. You could also spin up environments based on pull requests. It was very flexible and very dynamic, and had great support for Rails after the release Nix packs and stuff like that. So yeah, definitely loved using Railway, and now the production environment and all environments are Railway. Um, yeah, so yeah, that's where we are at now. ChemCloud um, is basically in a place where it's live, it's thriving, it's a great product. We had some stressful nights just trying to rush ourselves to finish the work. However, Rails helped us in a big way because Rails has a very strong community. Rails 7 came with so many things that were really good out of the box. For example, instead of Webpack, we were using ES now. ES gave us so much more than so less with such less configuration. It really went with a good philosophy of like having more convention over configuration. We didn't have to sit and configure and plumb our Webpack. Like I think in previous versions, the biggest problems we have had were upgrading Webpack versions and how things like post CSS and stuff would work with it. With ES build, that actually a lot of pain actually went away, and our configuration for JavaScript and front end simplified a fair bit. it played really well with TypeScript and Stimulus.js and Tailwind CSS. So we were actually like, we were really grateful on how Rails 7 approached the whole front end. We also switched a lot of things to in like from sprockets to say prop shaft and things that were very forward looking. So a lot of ecosystem that was being built with Rails 7 really played well with all the new things that were coming up, though they were not really well documented at that point of time. But we still didn't lose faith in it. We kept going. We kept looking at some of the GitHub issues. We also kept commenting on some of those GitHub issues and contributing to some of the documentation as well along the way. Um, yeah, so I think Rails 7 did help us in a big way to accelerate some of that development times, because it provided with a lot of those things out of the box. It was built in a way that gave us a lot of gain in terms of we didn't have to actually think twice before choosing anything. For example, the libraries that we want to go for, they're so standardized, accepted by the community. Let's go pick up device and run with it. Let's go pick up Pandit and run with it. Like it's such a no-brainer. View components that got standardized by GitHub. So we know some really good companies that use View components. It also gives us a great way to actually organize some of the code that we want to for our design system and future upgrades. So why not, right? Build a component hierarchy with it and stuff like that. Also, like we want to send out notifications. Notice Gem to the rescue. If we were to build this in like some other languages or like a lot of other frameworks, these tasks involve a lot of code, a lot of time. However, with a Rails ecosystem, the great thing is there's so many good libraries that are well maintained, they're easy to use. With just few lines of code, you actually get a full-blown notification system, or with a few lines of code, you just get an entire charting library and things like that. So um, yeah, mad respect for all the people who contributed to this community being so awesome. I think one of the things that saved us in terms of time was Rails 7 coming up with so many new features like ES-Build, Stimulus.js, and Hotwire Turbo. Um, uh, we actually were able to very effectively use some of these features, and also a lovely community that came to our help every now and then whenever we needed them. People would just comment and really go out of the way to help us with some of the issues that we had. A lot of times, things that were not documented, but people said, "Oh yeah, I have tried this before. Why don't you try it this way?" And you're like, "Oh yeah, I think this works now. Maybe it's good to document this. Let's do a pull request and document it." So yeah, it was kind of looking at this whole thing in motion, a framework being built in front of our eyes while we were using it. Um, yeah, that's what made it very interesting. And yeah, we had some issues. We had some uh, stressful evenings, but we did make it in the end. We did launch it, not Christmas exactly. We did launch it in first week of January when we came back, but we did build the whole platform in 2 months. So kudos to Rails for helping us in getting there. Yeah, thank you so much for your time today, and I really appreciate it. Yeah, thank you. Bye bye.
Yeah. All good. Keeps going off and shutting down Zoom, but pretty much it was just the next meetup is at Ripper in May 18th, and if anyone would like to do a talk, there is an opportunity. Selling this as an exclusive item. There's one opportunity, maybe more. Like the person says yes. So yeah, if you want to talk about stuff, then see what your schedule. And yeah, there's one every 2 months. Yeah. Thank you all for coming on. Thank you very much to Paloma for hosting us.